Okay, today we're going to talk about radian and degree measure. If you remember from Math 3, your unit circle, and I will give you a unit circle that you can refer to, but you do have to know your unit circle. You have to memorize it so that you can do all the trig that we're going to do in PreCal. So these are the measurements that we're going to be talking about, or the ones that you find on the unit circle for angles. So radian and degree measure. The first thing we're going to talk about is how you can convert back and forth between the two. So we're going to convert from radians to degrees. Okay. In order to do that, then you simply multiply by 180 over pi. For instance, if I ask you to convert 5 pi over 9, which is a radian measure, to degrees, then you just take 5 pi over 9 and you multiply by 180 over pi. Notice the pi's cancel. You can also say that 9 divides into 180 20 times, and then say 5 times 20, and that gives you 100 degrees. It is that simple. You would do the same thing if you had a negative radian. Say, for instance, you have negative 5 pi over 12, and we want to change that to degrees, then we would multiply by 180 over pi and do the same thing. Notice the pi's cancel. Okay, since both of these are even, then you can divide those out evenly by 2, and then you can keep going. I've done this for so long that I happen to know that 12 will divide evenly into 180 15 times. And then when you multiply negative 5 times 15, you're left with 75 degrees. Now, if you want to convert from degrees to radians, so you want to go backwards now. Well, if you're going to go backwards, then that means you're going to do the opposite or the reciprocal of what you just did. So you're going to multiply by pi over 180 to change from degrees to radians. So let's say that you have 200 degrees and you want to change that to a radian. Then you are going to multiply that by pi over 180. Okay, so I know in my answer I'm going to have pi up here at the top, and then I can simplify these. If I divide both of these by 10, those zeros are gone. I'm left with 20 over 18, which I could divide both by 2, and that leaves me with 10 at the top and 9 at the bottom. So my radian measure is going to be 10 pi over 9. And again, you can do the same thing if you have degrees, negative degrees. Multiply by pi over 180. Keep in mind, though, that if your degree measure is negative, then your radian measure will also be negative. You'll have pi left up here. And then you can divide these out. And I know that 15 will divide evenly into 180 12 times. If you don't know that, start with 5. Start with something you know that you can simplify that fraction with. Okay? But this will divide into 180 12 times. So that leaves me with negative pi over 12 as my answer. And I'm just going to shift that pi over a little bit closer to that negative. There we go. Okay, so that's all there is to converting, which is something you would have talked about in Math 3 as well. All right. for the next thing that we're going to do here, we're going to talk about coterminal angles. Coterminal angles those are angles that start and stop in the same place. You're probably wondering, well, how in the world that happens, okay? So glad you asked. Let's take a look at this. Change what my line looks like. Let's say that this is your y-axis, this is your x-axis. Okay, and let's say that we are going to draw an angle, okay, that starts right here on the positive x-axis. I'm going to make that line a little bit bigger. Okay, so we're going to start our angle right here on the positive x-axis, and we're going to rotate it around. Let's say we're going to rotate it around to right here. Okay, so we start this angle here. We're going to rotate it around to here. So this is the angle that we've got. Okay, so when I started my ray right here and I rotated this direction, I stopped there. Well, that's actually what we refer to as a positive angle. But I could also have started here and rotated this direction and stopped in the same place, and that's a negative angle. Okay, so if you go in the a positive angle, then that goes counterclockwise. That means you're rotating counterclockwise. And if you have a negative angle, then that means you rotated clockwise. Okay, so do you see how both of these angles, they started here and they ended there? So these two angles right here, that positive angle and this negative angle, they're coterminal angles. Okay, now this particular side right here where the angle started, which is on the positive x-axis, that is referred to as our initial side of the angle. And where we stopped, that's referred to as the terminal side of our angle. Terminal side, there we go, of our angle. Okay, so both of these angles right here, they started and they stopped in the same place, so that's why they're referred to as coterminal angles. All right, not only that, but you know, you're measuring these angles is based on 360 degrees being in a circle or 2 pi radians being in a circle. And what you'll probably remember, what I'm hoping you're going to remember from Math 3, is that you can have angles that are bigger than 360, and you can have angles that are actually smaller than 0, meaning that they're negative, and they could actually be smaller than negative 360 as well. It depends on how many times you decide to rotate this ray right here. So like if I started this ray right here and I decided to rotate it around more than one time, then that means my angle would be more than 360. If I decided to rotate it this direction more than one time, then that means it would be smaller than negative 360. So the measure of your angle depends on how far you rotated this ray right here that lies on the positive x-axis. By the way, when an angle lies on a positive x-axis, then that is referred to as an angle being in standard position. And that standard position means that the angle whose initial side lies on the positive x-axis. Okay, so I just felt like I needed to review all of that before I actually got into coterminal angles and how to find them. Okay, so in order to actually find coterminal angles, it's very simple, and it's all based on the fact that you have 360 degrees in a circle or 2 pi radians in a circle. So to find your coterminal angles, you're simply going to add 360 if your angle is in degrees, or 2 pi if it's in radians, and you will also subtract 360 or 2 pi to get your negative coterminal angles. And I guess I should have added right here to find positive coterminal angles. So if you want a positive coterminal angle, you can add 360 or 2 pi. If you want a negative coterminal angle, then you can subtract 360 or 2 pi. So let me show you exactly what I'm talking about here. Okay, so let's say that I want you to find a positive and negative coterminal angle for 210 degrees. Okay? Then all you do is you take your 210, and if you want a positive coterminal angle, then add 360 to it because it's in degrees. If it were in radians, you would add 2 pi, so I'm going to add 360. And that is going to give me 570 degrees. So that is my positive coterminal angle. If I want a negative coterminal angle, then I would simply subtract 360 degrees. And so my negative coterminal angle would be negative 150 degrees. It is as simple as that. Most of the time, sometimes you run into a little plot twist, though. Okay? It's pretty simple as long as this angle is smaller than 360. If that angle is greater than 360, that's when you can do some different things. So let's say that you're looking at a 500 degree angle. That's more than 360, right? Well, if it's more than 360, what I normally do is I start out subtracting 360 first instead of adding, because I know that subtracting 360 is going to give me a positive coterminal angle, and that positive coterminal angle is going to be 140 degrees. Okay, and see, if I were to add 360 again, you know, here I subtracted 360, but if I were to add 360, all that's going to do is give me another positive coterminal angle. Are you with me here? Okay, so that's why if this angle is bigger than 360, then I like to just subtract 360, get a positive coterminal angle, and then take my positive coterminal angle, 140, and subtract 360 degrees again. And then I know that that is going to give me a negative coterminal angle. So if I subtract 360 again, what is that going to give me right there? About negative 220. So here's my positive. This is what we refer to as the smallest positive coterminal angle. This is another positive coterminal angle. And this is my smallest negative coterminal angle. And I can show you exactly what that means by sketching these angles for you, why this happens right here and why you have more than one answer. Okay, so let me, I don't want a line that big. Let me get rid of that and get a smaller line here. No, wrong. Come on, Miss Letchworth. There we go. Okay, so here is my X and Y axis. Okay, and I am going to sketch these angles. I'm going to sketch that 500-degree angle first. Okay, I'm going to start right here in standard position. So I'm going to start on that positive x-axis right there. I'm going to rotate this around until I get to 500 degrees. So, and that's a positive angle, so I'm going to go in the positive direction. So I'm going to go this direction. This took me to 360, but if I want to get to 500, I've got to go 140 more. This is 90 more, and then I need about 50 more, and I'm literally just estimating that a little bit. Okay, so this is what your 500-degree angle right here looks like. Okay, it started here. I went in a positive direction, 360 degrees, and then I estimated 150 more. And the way I'm estimating is because, remember, in 360 degrees in a circle, if you were to divide it into 4 parts, each quadrant would be 90 degrees each. Okay, so 360 plus 90 more plus 50 more puts me at 500 degrees. Okay, so that's what my 500-degree angle looks like. It just means that it's a ray that rotated more than 360 degrees, or it rotated more than one circle. All right, now a coterminal angle was 140, right? I'm going to do that one in green. So that means that it started here and it just went to there. So that is 140 degrees. Do you see how the 500-degree angle and the 140-degree angle, it started and stopped in the same place? So they're coterminal angles. Now the negative 220, same thing. Okay, if I start right here on that positive x-axis for negative 220, the negative means I have to go in a counterclockwise. So you got to be careful, okay? Because going in a counterclockwise, going this far is negative 90. Here's negative 180. And then I need to go about 40 more. And right there's what negative 220 degrees looks like. Okay? And you see that all 3 of these angles, they're starting and stopping in the same place. And actually what I could do if I wanted to is I could, trying to change my colors here. Okay, there we go. What I could do is I could actually come right here and I could rotate around as many times as I want to in a positive direction. And I could have infinite coterminal angles in a positive direction. I could do the same thing in a negative direction. I could start here and I could rotate around in a negative direction as many times as I want to. Okay, so my point is this: you have the possibility of infinite positive and negative coterminal angles. But what I'm going to always ask for on quizzes and tests is the smallest positive and the smallest negative coterminal angle. Okay? All right, so let's do a couple more here. All right? Let's say that you have a negative angle to start with. And I want a positive and a negative coterminal angle. Well, if I start at negative 450 degrees and I subtract 360, Well, I know I'm going to get a negative angle there, right? Which is fine. I want a negative angle, okay? So you can go ahead and do that if you want to. And that's going to give us, what, negative 810 degrees? Okay? And then, of course, I can add 360 as well. Okay? What's going to happen here, though, is I'm going to end up with another negative coterminal angle. And that negative coterminal angle is going to be negative 90. Well, remember, on quizzes and tests, I'm going to always ask you for a positive and a negative coterminal angle. All right? I don't want two negatives right here. All right? So what I need to do is I need to take where I left off right here at negative 90, and I need to add 360 again so I can get myself a positive coterminal angle, and that positive coterminal angle is going to be 270 degrees. So these are the two answers that I'm going to want right here, and that's because this is your smallest negative coterminal angle, and this is your smallest positive coterminal angle. Okay? Now, if in my little video here you're not quite getting what I'm talking about, you need to email me, you need to ask me, send me a remind message or something, okay? Let's talk about radians, okay? Now that we're in radians here, then we're going to be adding and subtracting 2 pi. So I am going to take 3 pi over 6, okay? And I'm going to add 2 pi. Get hooked on fractions because you will not have a calculator, okay? 2 pi, or 2 is the same thing as 12 pi over 6, right? So if I add these together, I get 25 pi over 6. So there's a positive coterminal angle, all right? Now let's subtract it, though. And let's see what happens when we subtract 2 pi, meaning that we're subtracting 13 pi over 6 minus 12 pi over 6. Well, again, that gives me a positive. Remember, I want a positive and a negative. So if I want to get a negative, then I'm going to pick up right here with my smallest positive coterminal angle, and I'm going to subtract 2 pi again. So pi over 6 minus 12 pi over 6. And that gives me negative 11 pi over 6. Okay? So these are the two angles right here that I would be looking for. All right? So that is what we mean by coterminal angles and how to find your coterminal angles. Okay? So next concept here, complementary and supplementary angles. Okay, complementary angles, they add to give 90, right? 90 degrees. Or if you're in radians, it would be pi over 2. Now, if you don't remember that 90 degrees is the same thing as pi over 2, then you need to refer to your unit circle. Supplementary angles, they add to give 180 degrees. Or refer to your unit circle and you'll know that that is the same thing as pi. Alright, so let's say that I want you to find the complement and the supplement of pi over 5. Or actually, let's start with degrees. Let's say I want you to find the complement and supplement of an 80-degree angle. Okay? Then to find my complement, then I would simply say 90 minus 80, and my complementary angle would be 10 degrees. That's because 80 plus 10 is 90. Okay? And for my supplement, I would do 180 minus 80, and my supplement is 100 degrees. That's because 100 plus 80 is 180. Okay? The complement of a 120-degree angle, well, there is none. Okay? That's because complements and supplements, they cannot be negative. All right? Because if you were to do 90 minus 120, you would get negative 30. And again, complements and supplements, they cannot be negative. So if that happens, you would just say none, that there is no complement to this angle. Now, you do have a supplement because when you subtract 180 minus 120, you do get a positive angle, and that is okay. So complements and supplements, they have to be positive angles. Must be positive. Okay? All right, let's look at see what that looks like with radians. Let's say that I want you to find the complement and supplement of pi over 5. Well, just like with degrees, I did 90 minus whatever my angle is. Since this is in radians, I'm going to do pi over 2 minus whatever my angle is. Got to get some common denominators here. Common denominator is 10, right? Multiply these two together. Multiply these two together. And you end up with 3 pi over 10. We can keep that answer because it's a positive angle. If that had ended up being a negative, we would throw it out, just like we did here. All right, the supplement, we're going to do pi minus pi over 5. Get that common denominator of 5. So cross multiply here, 5 pi minus, remember that has a denominator of, understood denominator of 1. So if you cross multiply there, then that's 1 pi. And that gives me 4 pi over 5. Okay, I'm going to keep both of these because they're positive. So again, they have to be positive, and they have to be positive angles. Your complements cannot be negative. Neither can your supplements be negative. Okay. All right. Let's talk about arc length a little bit here. Okay, arc length. Ooh, I can spell better than that, I promise. Okay, I can write better than that. There we go. Arc length of a circle. This should be reviewed from Math 3 as well, but it's defined as S equals R times theta. That's your angle theta. And I am saying this word right here, it's a Greek letter, theta. If you have a circle, all right, so you have this circle right here, then of course you know that this is your radius. And if you rotate that radius around your circle, and say that you rotate it until you get to here, then what you did is you rotated to form an angle. I'm going to move that R. I'm going to put it right here. So there's your R for your radius. And this angle right here is theta. Okay? Theta for this is always measured in radians. Theta is your central angle. That's what we refer to as the central angle, because theta is at the vertex of that angle is at the center of the circle. And of course, R is your radius. And S is the arc length. So, Number 12, let's say that you have a radius of 4 inches and that theta is 240 degrees. Well, the first thing you have to do here is convert your degrees to radians. And remember, to convert degrees to radians, you multiply by pi over 180. So when I multiply this by pi over 180, then I'm going to get 4 pi over 3. And all I did was I divided out my 10 right here, and then I divided 6 into 24 to get 4, and 6 into 18 to get 3. So theta is 4 pi over 3. All right, and then I'm going to plug all of this stuff into our theta. So my arc length is going to be 4 times 4 pi over 3. So therefore, my arc length is 16 pi over 3, which is exactly how you can leave it. And this is inches, by the way. And so that's exactly how you can leave it if you don't have a calculator. If you have access to a calculator or you are asked to use a calculator and to convert this into decimal form, then it would be 16.76 inches. And arc length simply means that that is the distance around that circle. So arc length means that I went 16.67 inches all the way around. In other words, it's circumference of your circle. It's what you would get if you were to take that circle, cut it apart, and stretch it out into a line. Now, area, let's talk about area for just a second. What we refer to as the area of a sector. Okay, that formula is area is equal to 1/2 r squared theta. And again, theta has to be in radians. So let's say that you wanted to find the area of a sector. Okay, let's say that this is your circle right here. And here is your radius. And let's say we have another radius drawn right there. And that the area of the sector that I want to find, let's say it's this sector right here. It's a piece of pie. Thanksgiving's coming up. Everybody's going to be eating pie, right? Okay. So you want to figure out what the area of this sector right here is. So suppose that I told you that the radius of this circle is 70 inches, and that this central angle right here is 120 degrees. Okay, so to find the area of that sector right there, I would just plug everything into this formula. Okay, so I would say that the area is equal to 1/2 times 70 squared times 120. So I'm going to make this a little bit easier and go ahead and do half of 120, which is 60 times 70 squared. So that's 60 times 70 squared. If you square the 7, you get 49. If you square the 0 or the 10, you get 100. So that gives you 2 zeros. So that would be simply just saying, oops, I forgot something. I forgot to change my degrees into radians. Oh my goodness. Come on, Miss Letchworth. Man, I was hustling on that problem, wasn't I? Okay. So I need to change that 120 to radians. Okay. Or you can look at your unit circle, and you actually maybe should have that memorized. and you would know that this is actually going to be 2 pi over 3. So I'm going to multiply this by 2 pi over 3. Okay, I can still say 1/2 times 2 right there. So that would be pi over 3 times 4,900. I can still do that part, which is the same thing as 4,900 over 3. 4,900 pi over 3. I would leave it like that if I didn't have a calculator. Otherwise, you can use your calculator and it will tell you that it's 5,131.27 squared inches in this case. So that is how you find the area of a sector. Okay, so let's talk about linear, what we refer to as linear speed. Get rid of that little stray mark right there. Okay. Linear speed, that means how fast something is going. So we use V because speed is the same thing as velocity. So V is going to be your speed, and you're going to take your speed and you're going to divide it by your arc. You're going to take your arc length and divide it by your time. Okay, so V is your speed, S again is your arc length, and T is time. Okay, so let's say for this particular example here, I think this is actually number 14. Okay, so let's say that you have been given that R is 10.2 centimeters and that your time is 1 minute, or 60 seconds rather. Let's make it 60 seconds because most of the time we do our time in seconds anyway. And so you've got a radius of 10.2 and you want to figure out how fast something is going around a circle, and you're going to go all the way around the circle, meaning that theta is going to be 2 pi. So you want to figure out how fast it's going. What is its speed? Okay, well you've got to find arc length first. So we're going to do r times theta to find our arc length first. And again, if I didn't have a calculator, then I would just leave this as 20.4 pi, which I would want to do anyway because you really shouldn't round in the middle of your problem. Okay. Then once you know what your arc length is, you can find your speed, v, which is velocity, by saying 20.4 pi divided by 60 seconds. And this is centimeters, by the way, because the length around your circle would be in the same units as whatever your radius is. Okay, and then you can use the calculator to divide all of this stuff out, and it will tell you that its speed is 1.068 centimeters per second. And what that refers to is how fast something is going around that circle. You had something that started here and it started moving around that circle. So it's moving at 1.068 centimeters per second. Okay, so that is all of the first lesson. Okay, all right, so remember, email me or message me about any questions you might have.